Okay, in this video I show you how to use the NormalDist formula to solve Chapter 6 normal distribution problems. And this is a little complicated word problem, but what we're looking at is starting in this section right here. That's what we're trying to solve for. We have a car company who claims that their mileage of a particular model averages 33 gallons with a standard deviation of 0.7. So if that's true, what is the probability that my mileage would be between 32 and 35 miles per gallon? We know that the mileage is normally distributed with an average of 33, a standard deviation of 0.7. So I want to know the chances that I would have cars, because that doesn't mean all the cars have 33 miles per gallon, that's just the average. So I want to know what are the chances I would be between 32 and 35. So let me show you how to solve this. We're going to solve first of all this problem, the probability that the mileage is less than or equal to 35. And that is, we're going to use the NormalDist. You put in your x value, the value on the horizontal axis, which is this value, 35. Then you put in the mean. You put in the standard deviation. The last argument when you use the NormalDist formula is always 1. Always. Never put anything else. So that are the chances that you would have a car with the mileage less than 35%, which solves part of this problem, but we have a lower bound of 32. So I've got to take off that little area, the probability that mileage is less than or equal to 32. And that's going to be NormalDist. You put in 32, put in your mean, put in your standard deviation, and the last argument is always 1 when you use the NormalDist and that. So to solve for this, you take this number and you subtract this number, and that will give you that band between 32 and 35, 0.921. And I'm going to go over here and scroll down. So what we just solved for is this blue area. This area, this 0.997, is 35 all the way. It's all this blue, but we got to subtract off this little sliver here. That's what this is. So when you take this number and this number, you wind up with this blue area. Now the way they solved it in the book, and that's the right answer, right there. That's the right answer, right there. There you go. There's the answer. There's the answer in both of them. But how they solved it in the book is they actually solved it as going to a z-score. So let's calculate the z-score for 35 and 32 and do the same thing. So first of all, the z-score for 35, that's just equal to 35 minus the mean in my numerator divided by the denominator. And then my z-score for 32, same thing, 32 minus my mean divided by, divided by my denominator. And that's what these numbers come up with here, 2.86 minus 1.43. That's what these numbers are. And then I could use the same technique. I'm going to use this exact same technique. So the probability, you could use the back of the book. You could look these numbers in the back of the book and find the areas and subtract that areas, but I'm going to use the NormalDist. So the probability that my z is less than or equal to 2.857 is use NormalDist. I put in this number. On a standard normal, the mean's always 0, the standard deviation is always 1, the last argument's always 1. And look at there, that number is the same as this one. So we're solving the same problem after we converted it. Z is less than or equal to minus 1.428 equals NormalDist. Put in this number. On a standard normal, 0, 1, 1. There you go. This number is this one. This is this one. So the probability of being between minus 1.428 and 2.857 is this area minus this area. There you go, the same thing. You solve this problem, you've also solved this problem. The cool thing about Excel is I don't have to go through this effort. I just used the original numbers. I didn't calculate a z-scores. Z-scores are important to know, but when you're trying to solve these normal distribution problems, you can skip this step and just solve this one. Thanks.